Okay, we're going to go over the homework for 8.2.2, okay? All right, let's start with the first one. Assume figure A and B at right are similar. So we're assuming they are similar. If the ratio of similarity is 3 to 4, what is the ratio of the perimeter of figures A and B? So when it says 3 to 4, it means this is 3 and this is 4. And so remember, we talked about this in the previous lessons and the homework, that the perimeter has the same exact ratio as the scale, right? So the ratio of the perimeter will be the same. It will also be 3 to 4. If the perimeter of figure A is P, okay, so the perimeter is P, and the linear scale factor is R, what is the perimeter of figure B? So the scale factor is R, so you need to multiply by the scale factor to get the perimeter of this one, right? You're not going to change the number because the scale factor and the ratio of the perimeter should be the same. So the perimeter of figure B should be P times R. If the area of figure A is A, okay, so if figure area is A, and the linear scale factor is R, what is the area of figure B? Now, if it's comparing the area, you need to take the scale factor and square it. So you got to square the scale factor and then use that to figure out the area of figure B. So then the area will be the A times the scale factor squared, and that will be the area of figure B. It's very abstract, meaning there's no number, so it's a little harder to see. So the idea is that if it were, for example, this is 1 to 5, the scale factor is 5, right? So the perimeter will be P times 5, this will be 5P. But if it's area, then it'll be area times 5 squared, and this will be 25 times A. And that's what this is talking about, okay? So hoping the numbers will help you see the relationship a little bit better, okay? All right, move on to the next one. Always a romantic, Maris decided to bake his girlfriend a cookie in the shape of a regular dodecagon, that's 12agon for Valentine's Day. If the edge of the dodecagon is 6 centimeters, what is the area of the top of the cookie? So we're looking for the dodecagon, right? Now remember, we can use triangles to help us. So if we recall, a dodecagon has 12 sides, right? So we can use a lot of things to help us figure out. First of all, we know there's 12 triangles in there. So we know we can have 12 times whatever the triangle is. So let's figure out the triangle. So off this side here, I'm going to draw myself a little picture, right? Remember, those triangles are always isosceles, so I know that for sure, right? And then what about this angle here? Well, then that is half the interior angles. So I take 12 minus 2 times 180 divided by 12, right? So I got to use my calculator to help me. So that's 10 times 180 divided by 12. Each interior angle is 150, but we got to take half of that. So this angle here is 75, okay? We also know the edge is 6 centimeters, so the edge here is 6 centimeters. But remember, in order to make this useful for us, I'm going to zoom in for you, we only need half of it. So half of it is 3, because that half is going to help me figure out what this height is, right? And we need that. We need the base and the height to figure out my triangle, right? So now that we have this 90-degree triangle, we have our awesome SOHCAHTOA to help us. We're going to say tangent of 75 equals the opposite, which is the height I need, over the adjacent, which is the 3. So then you go 3 times tangent of 75 equals the height I need. So I'm going to take my calculator, lots of calculators in front of me, take my calculator and go, okay, 75 degrees tangent times 3, my height is 11.196. okay, all right, so that means then I can figure out the triangle. So the area of the triangle, I'm going to erase this because it's in my way. All right, the area of the triangle is 1/2 base is 6, times the height, 11.196. Okay, so 11.196 times 3. That gives me each triangle to be 33.588. So the dodecagon, so the total area is 12 times 33.588, because there's 12 of these triangles, times 12, and I get 403.056 square centimeters for the cookie, okay? His girlfriend decided to divide the cookie into 12 separate but congruent pieces. After 9 of the pieces have eaten, what area of the cookie is left? Okay, so if she ate 9 of the 12, then there's 3 pieces left, right? Because you get 12 minus 9 gives me 3. So she has 3 out of 12 left, which reduces down to 1/4. So we need to take 1/4 of the original area. So 1/4 times 403.056, or in other words, take your 403.056 and divide it by 4. you will have 100.764 square centimeters left. Okay, and that would be how much cookie is left. Okay, next one. As her team was building triangles with linguini, so you have your coffee stirrer from last semester too, Karen asked for help building a triangle with sides 5, 6, and 1. I don't think that's possible, said her teammate Kelly. Why is this triangle not possible? Because the two shorter sides, if you add them up, 5 plus 1 is exactly 6. You don't have enough to push the triangle up to make that triangle. You have to be greater than. The two short sides combined, right, added up, must be greater than the longest side. Okay, change the length of one side so the triangle is possible. So a simple change of making this one a 2, because then you get 5 plus 2 is greater than 6. So change the 1 to 2. Or you can change the 5 to 6. As long as you add more to these two sides, even 0.5 will help, right? So even a little tiny bit will help. You just need to be greater than 6, okay? All right. Next, we're back on our series and sequences. Let's see what's happening here. I see that, my numbers are going down by a half each time. So subtracting 1/2, not so bad, okay? So formula first. A sub n equals the first number, 17, plus n minus 1 times that common difference of 1/2, right? Okay, so I'm going to go ahead and clean this up. 17 plus, not plus, minus, because it's distributing a negative. Negative n over 2 plus 1/2. So it's 17.5 minus n over 2 for a sub n. Okay, now I need to look for the 150th term. So a sub 150, because it's looking for the 150th term, is 17.5 minus 150 over 2. Well, that's not so bad. 150 over 2. So you get 17.5, so 17.5 is a little easier working with decimals in this case. Minus 150 divided by 2 is 75. So 17.5 minus 75, I would get a negative number, negative 57.5. But to make sure I keep with the same idea of the original sequence, I'll just rewrite that as negative 57.5. Okay? All right. Next. Callie started to prove that given information in the diagram at right, then A, B is congruent to C, D. Copy your flowchart on your paper here. Justify each statement. Okay, we're going to look at what we have here. Okay, so what is given to me? It has told me that these two lines are parallel. Okay, so why are they telling me that these are parallel? Because then we have some relationships here, right? We have a transversal here, and that gives me alternate interior angles. So let's check which one is that. That's angle ADB and angle CDB. Oh, there's two sets of alternate interior angles. They were using the other one. That's okay. That works too. Another set of alternate interior angles will be here as well, right? Here and here. All right, so these are alternate interior angles. Okay. Now, what about angle A, angle C? Well, it's already marked there, so it's given in the diagram. And then we know that, okay, sorry, I want to mark everything I do know. I know these two angles are congruent, and I know that BD is congruent to BD because of reflexive property, because you're looking at yourself in the mirror. So now looking at this triangle, I have angle, side, that's proven they're congruent. So angle, side congruence proves that we have congruent triangles. And then because of that, I can then say, I already have congruent triangles, then A, B, and C, D must be congruent because they are corresponding parts of congruent triangles, and they are congruent. All right, CPCTC. Beautiful. Okay, for each pair of triangles below, decide if the triangles are congruent. If they are congruent, state which triangle congruence property proves that triangles are congruent, and then write a statement. Okay, so I have some parallel lines again, so I can see my parallel lines. Parallel lines, and I have my transversal. Okay, looking very good. All right, so I have my alternate interior angles, very good. And I have a side they share. So this one's congruent by angle, side again. So I can say triangle ABC, congruent to triangle, make sure you follow the right order, DCB, by angle, side, congruence. And that concludes both the congruent statement and the property. Okay? Over here, what do we have? Well, it looks like I have right triangles, but I don't have enough to use hypotenuse leg. I only have the legs congruent here, but I do see that these are vertical angles. So I actually have a good property here. I can use angle, side, angle, right? Look at the difference, compare the two, compare part A to part B here. Why is the first one angle, angle, side, and the second one's angle, side, angle? The side in this second one, the side here is touching both angles. That's why this is called angle, side, angle. Okay, all right, I think I have enough. So I can go ahead and say triangle ABC congruent to triangle EDC by angle, side, angle congruence. Okay, beautiful. Last one, what is the solution to system equations at the right? Okay, so for me, I can see that the first equation is already written as y equal. I'm going to go ahead and plug that into my second equation here. This is substitution back in Algebra 1. So x minus 4 times 1/2 x minus 4 is now your equations all in x's, right? Distribute your 4. So x minus 2x minus 16 equals 12. That gives you minus x equals minus 16 equals 12. 16, so you get 4. Oh, so not 4, 20. A lot more than that. 28, right? And then you have x equals negative 28. Okay, all right, now you take your negative 28. Oh, that's looking not so good. I don't see my answers there, but I'm going to quickly check. All right, this is always, I make mistakes too, so I always want to make sure that I'm not making a mistake here. Oh, I did. This is a plus 16. That's why. Okay, all right, that makes it a lot better. So if I subtract 16 on both sides, see, this is why I can't skip too much. So if I subtract 16 on both sides, I get negative x equals negative 4 divided by negative 1, so x equals 4. Nice. All right, now you can go ahead and plug that x equals 4 into this original first equation. So you can now say y equals 1/2 times 4 minus 4. Half of 4 is 2, minus 4 is negative 2. So y equals negative 2. So your answer is 4, comma, negative 2 as an ordered pair. Okay, that's it, guys.